So this brings us to a very useful test to see whether or not a relation is just a plain old relation or if it's a function. Okay, there's this test that comes up a lot in math called the vertical line test, or VLT for short. And the vertical line test basically says this. If you can take a vertical line, it's a line that goes straight up and down, and move it anywhere on your graph, on your relation, if that line touches that graph only once, no matter where you move that line, it's a function. If it touches that graph in two or more places, it's just another relation. So I'll show you what I mean. Okay, I'm going to grab this line, and I can move it. Check it out. Woo! Okay, so I take this blue line and I move it across this relation here. How many times does that vertical line touch that graph? Maximum number of times. How many times does it touch it?
Infinity.
Wherever I put it, if I leave it there, how many times does it touch? Once, right there. Right? It touches right here. Right? It's not going to let me erase, so I've got to make a new one. If I move it somewhere else on my relation, say here, how many times does it touch? Once. If I move it here? Twice?
Well, if it's up in line, maybe? Oh, okay.
The y-axis does not count as part of the relation. Right? If I move it anywhere on this function, on this relation, it will only touch once. Okay? That's an indication that this is a function. Okay? So this is a function because it passes the vertical line test. It can only touch the function in one place, and that's it. Or no places, but one place maximum. Okay? Let's look at this this function down here. I keep saying function. Relation, sorry. Okay? If I do the vertical line test on this relation, is there anywhere where this blue line touches that curve more than one time?
All over.
Right here, right? You can see it's touching once here and once here. So that's two times. So this is a relation. And in this case, you could say that the value of 8 for x, if you just kind of look closely, it's a little blurred on my screen, but this is the value 8 for x. It's tied to two values in the relation. So in a table of values, if I input 8 for x, I could potentially get two values for y. So this is not a one-to-one correspondence. Okay? That one value for x is tied to more than just one value for the y's. All right? Let's do the vertical line test on this V-shaped graph, which is called an absolute value function. Oh, I've said it again. Stop doing that. You can probably tell by now, though. Okay? How many times does it touch maximum?
Just one.
Once. No matter where I move that line, it only touches once. So this is a function. Okay, I should have labeled the other one relation. Okay. What if we have a set of ordered pairs, some dots? How many times does that line touch these dots maximum, or this function, or this relation? Sorry. Yeah, it touches once there, and once there, once there, once there, once there, once there. So this is a function. Functions only touch once. Okay, this is a function. Doing the vertical line test on this last graph up here. Is there anywhere I can move this vertical line so that it touches this relation more than once? Yeah, right here. This time, this x value, which is -2, is tied to 4 y values. Okay? So this would be just a relation. Just some other relation. Oh, I missed one. There's one at the bottom here. Can you see it on the circle here? What is this? A relation or a function?
A function. Oh.
It's a relation because it touches more than once, right? If I draw a vertical line here, I touch twice. Okay, so that's for me, that's the best way to know whether or not a relation is a function, is if it passes or fails the vertical line test. All right? In a table of values, you can identify whether or not a relation is a function by looking at what these x values spit out. Right? I know, just looking at the table of values, that this is a relation because when I input negative 4 for x, I get potentially two values for y. Whereas over here, every time I put in negative 3 for x, I only get negative 3 for y, and that's it, nothing else. Does that make sense? Okay. Maybe another table I could use to demonstrate that is x and y. If I put in, I'm just making up numbers here, negative 2, I get 3. If I put in negative 1, I get 4. Put in 0, I get 5. If I put in negative 2 again and got 3, and put in negative 1 again for y and got 4, and if I put in 0 again for x and I got 5, would this be a relation or a function?
Function.
This would be a function, because every time I put in this negative 2, I always get 3. And every time I put in negative 1 for x, I always get 4.
So as long as they equal the same thing and not two different answers, then it's a function.
Every time you input any of these values for x, you always get the same number. You always get one number. But if I made a table that looked like this, x, y, and had the same x values, negative 2, negative 1, 0, negative 2, negative 1, 0, and my y values look like this, 3, 4, 5, 6, 7, and 8. This is a relation, because here I put in negative 2 for x and out popped 3 for y. Down here I put in negative 2 for x and I get 6 for y, something different. Okay, so this would be a relation because it pops out different values for the output variable. Okay, when I taught this the very first year with this year's grade 12s, they made up this interesting analogy to help remember the difference between a function and a relation. Okay, if you imagine, I'll use this example because it's nice. The set of x values, the domain, as a bunch of hormonal teenage boys who want girlfriends.
Wow.
It's just like shock. Okay, and imagine the y values as a group of dignified young women.
Wow.
Okay.
It's quite the jump.
It is improper, and this is very terrible relationship advice, but it does help you remember what a function is. It is improper for a man to court more than one woman at a time.
How's that a terrible relationship?
Correct?
Advice?
Go try it.
You're gonna get slapped.
Yeah. Right? If I'm a guy, it is unacceptable if I date more than one woman.
Oh, like that. Oh, I thought I had it backwards. I thought
Okay.
like, no.
So that's the picture I'm trying to paint here. Is negative 3, the man, is tied to negative 3, the woman. And no other woman. Whereas here, this guy's cheating. He's tied to 4 and negative 4. Bad. However, because this is a set of dignified young women and they can handle that degree of complication in their life, women are allowed to date as many men as they want.
Wow.
So that's why you can have these ones here connected to 1, 2, and 3 for x, but it can't go the other way around.
What?
So guys can only date one woman, even if it's the same woman.
One woman.
One woman. Girls can date as many guys as they want at the same time.
That's
That
pretty terrible.
That sounds so
This is
unfair.
on
And that is
YouTube.
only
I'm kidding.
a math illustration. That's it.
Mr. Greenlaw, you're still recording now.
I know. I want the whole world to hear that.
Really?
Yes.
Oh no.
Well, at least it's not live, right?
So you understand? Functions, guys can only date one girl. Girls can date as many guys as they want, but guys can only date one girl and that's it. Relations is just bad news.
You don't
Guys and
want
girls
to-
can date as many as they want.
You don't want a relationship.
All right. Good.